So what I'm going to talk about today is basically what Tamr does and the common strategic approaches that we see folks taking to trying to solve different problems around data variety. So I'm Eliot. I run data science for Tamr. Basically, I work with our largest customers to actually deploy their data lake strategies very commonly. And what I'm going to talk about is sort of the common strategies that I see and what works and what doesn't work well. So just a little bit of quick background on me and the company. So what we do and what our largest folks do is that we try to solve the problem of data variety, right? So the problem of many sources of data being pulled together, right, and being pushed into very specific applications and very specific analytics. Now, what most enterprises think about today, and what most of them think that their challenge is how do you deploy machine learning? How do you use all of these new analytic and predictive analytic techniques? But in fact, one of the biggest challenge is that the executive view that organizations have all of this well-structured data, all of these well-formatted tables, is completely incorrect. In most cases, the organizations that we deal with have been through countless M&A, have thousands of systems, and are dealing with the mess that's involved with trying to bring these different systems together and actually build analytics. I was talking to someone yesterday that was very proud they had 80% of their data that was captured in a data lake of all of the enterprise's data. But I bet that when you actually go and you look into that data lake, you're probably going to see something that looks like this, right? A lot of spaghetti that isn't necessarily easy to parse. Now, the folks that recognize this as a problem, they have a couple of different approaches that they try to take to actually solve this problem. And where they see their role is as a data broker, right? How do you actually create these curated data sets and hand those off to people in the business that actually are trying to do work with data analytics? So I normally see three different strategies that folks try to take to solve this problem. Number one, they don't try to solve it at all. They ignore it. Number two, they try to use the sort of traditional approaches of someone like an Informatica, right, to bring data together and in a rules-based way create these curated data sets. And then option three is that they say, okay, well, we're going to have this mess for a while. It's going to be a very large mountain. How do we not just chip away at this mountain, but how do we actually have a solid strategy for going after this? Use a probabilistic approach for managing all of this variety at scale. So let me quickly walk through these three and give a little bit of context. So the deny variety case is always the most fun. Basically, it's give folks the ability to get the data that's closest to them, right? I talk to a lot of quants at hedge funds, right? Quants are usually physics PhDs that are incredibly smart, and they're very resourceful about getting data, but the only data that they have access to is the data that's closest to them. So they don't actually try to solve the variety problem, they just try to grab whatever's closest. So option two is to manage this data variety incrementally. And there are 6 different ways I've seen this done. The first is we're going to standardize all of the sources across the enterprise, right? I'm a large manufacturing company. I maybe have 300 different ERP systems. I'm just going to make all of those SAP systems and Oracle systems look the same. And then when I put it into my data lake and when I put it into my great data warehouse, right, we're going to be able to we're going to be able to run analytics on top of all of that data. Option two is aggregation. I'm going to stick all of my data into a Hadoop cluster, into HDFS. I'm going to do full replication of star schemas, right, from application systems and relational systems and unstructured data sources. I'm going to put it all into my data lake, and I'm going to begin to run analytics and run aggregations of that data across those different sources. This is, by the way, none of these things are bad things, right? They're all great, but they all are incremental approaches to trying to solve this problem. Option 3 is an interesting one, master data management. We're going to have a single master system, right? And the single master system is going to then feed all of my downstream systems. And with my master data management system, I'm going to have clean and curated data that then my analysts can use. I'm going to have my set of customers. I'm going to have my set of products. And we're going to be able to understand at an enterprise level that master data. Number 4 is to rationalize systems, right? Number 4 is, we are basically going to take all of our different applications and recognize that we can probably get rid of 80% of those things, right? We just need fewer SAP and Oracle systems, right, in our enterprises, in our global 2,000 companies. And with fewer systems, right, we're going to be able to achieve the data analytics that we're going to want to achieve. GE is a phenomenal example of an organization that's actually been able to do this really well. They started off with 550 ERP systems, very, very publicly, and they had a 4-year project to get down to 120. So over 4 years, they got rid of 100 ERP systems a year, which is thousands of developers, working around the clock, right? But still, at the end of the day, they have 120 systems, right? So, their rationalization was incredibly valuable. It unlocked a lot of value, but it wasn't able to get them to the data management that they need. Option 5 is to throw bodies at the problem. We're just going to hire a systems integrator, or we're going to hire a lot of folks that are going to, manage and munge this data. And usually we're going to get really great rates to solve this problem, but fundamentally we're going to do it manually. And then option 6, which I think is the most common option if you walk around the floor today, is that we're going to radically improve the individual productivity of each of our business analysts. Right, so we're going to give our business analysts new tools, right, in order to help them be more productive. Doesn't necessarily solve how you want your organizations to look. It doesn't necessarily solve, the processes that you have in place. But at least if you're using stuff that's better than Excel, right, you'll be able to bring data together more effectively. Now, none of these things are each of these approaches are great. They work phenomenally in the niche use cases that they have. But my conjecture is that these things are necessary but not sufficient to fully solve the problem of bringing together thousands of data sources at scale. And where we believe the world is going is that today, most of the systems around doing ETL, most of the systems around doing master data management, most of the systems around pulling data sets together are fundamentally deterministic. I'm a programmer, I write a set of rules, I have lineage in those rules, and I'm able to bring data together programmatically. There are a couple of cases when folks are using probabilistic stuff in the enterprise today, but it's very rare, right? In some master data management systems, they have modules that do something like this. You may have developers that build homegrown tools. You yourselves may use correlations and use machine learning in order to try to stitch data together. But but as we move to the future, as we look at the design patterns within large enterprises like Google and Facebook and Airbnb, and the way that they bring data together is that they use these probabilistic approaches, these machine learning driven approaches in order to bring data together effectively at scale. And when you go to Google and you go and you talk to what are equivalently their ETL developers, right, you're not going to see a lot of folks that are, in a very deterministic way, right, building rules that bring data sets together. You're much more likely to see data ingestion that's done automatically or semi-automatically. So we have a fundamental belief of the different components that go into that, and if you want to learn more, feel free to go to sort of the booth. and I can tell you much more about that there. But what I sort of want to leave you with is that where I believe the industry is going is that data and the data that these enterprises are pulling together is going to be a competitive advantage, not the algorithms and the machine learning that's built on top. It's sort of painful. I'm a machine learning guy. I love algorithms. But when you go to large enterprises, they're much, much more focused on building these moats of data, these very valuable data sets, rather than the niche algorithms on top of those data sets. And they see the data itself as the competitive advantage, rather than what's being built on top of it. So I'm going to leave you folks with that. Hopefully there was some interesting stuff here. But if you want to learn more about Tamr, or if you want to talk more about this, I'll be over at our booth over on the Tamr side in, I think, aisle 200, and happy to take any questions afterwards. Thanks so much.